Hello, this help video is going to be for Unit 2, Lesson 3 on algebraic expressions. I'm getting some questions from students about the vocabulary. So you do want to spend some time making sure that you understand the vocabulary. It's pretty impossible to access the math if you're not understanding the terms and the vocab, what we're talking about, and what things mean. So for help with the vocab and to kind of get a list of what you need to know, you can click on the lesson link that you're working on from the message board. That'll take you here. You can open up your notes and you can go ahead and download these. And I'm going to do that so that I can actually take notes in the document itself. All right, so here you're going to find a list, what you should be able to do after you're completed with the lesson and the practice, and then here we have our keywords. This is the vocab. This is the kind of vocab you're going to see on the assignments, so you have to know what they mean when you're using all of these. So for this lesson, you're going to be working with algebraic expressions. So I'll start with just an example. Okay, to help you kind of fill in what each of these pieces mean. So your coefficients are going to be the number in front of a variable. So my coefficients in this example are going to be 3, telling me that I have 3 y's, 2 x's, and 5 y's here. Okay, this number is not a coefficient because it's not in front of a variable. So my coefficients for this case are 3, 2, and 5. They tell you how many of the variables I have. All right, constant term. Your constant terms are going to be your numbers. Okay, a constant, when they say that something's a constant, it means it doesn't change. So our only constant here, it's going to be this number that's all alone by itself. Okay, let me add that note. Okay, so your constants, they don't change, they always stay the same. Your variables, that's the piece that's changing, varying, right? So 3y is not a constant because it has a variable, and that y can represent different values that might change. So maybe in one instance y is 2 or y is 3. So that's varying. Its value is changing. But there's nothing to change the value here. It's just 3 every time. So that's your constant. So 3. Okay. All right, what does it mean if your directions are asking you to evaluate? Right, so if you are trying to sell your house, you might have someone come and do an evaluation on your home, right? That's figuring out the value. Okay, and you need extra information in order to evaluate. So they might come and say, well, I can't evaluate your house. First, I need to know how old the house is and where it's located, and then I can tell you what its value is. So when you're evaluating, you're given a value, and then you're going to substitute that into the equation. So for example, if I say, okay, y is 2 and x equals 1, now I can evaluate it. The y value is a 2. The x value is a 1. The y value again is here a 2, and then I'd add 3. And then let's open up my calculator. Remember, you can use your calculator at all times in the course, so feel free to use it as much as you need to. There's a link to download this version and some help videos there. So now I know the values for y and x, so now I can evaluate this expression. Okay, and its value is 21. All right, I'm going to skip and do terms next. Let's do that in green. Okay, your terms are your parts or pieces to the problem, to the expression, sorry. Parts or pieces. Okay, and then when you're finding terms, you have to pay special attention to your like terms. All right, so let's see, what's the best way to explain this? Let's say I've, bringing in snacks to my meeting, and I have 2 bags of M&Ms and 1 Snickers. Okay, so for the terms, you want to combine the like terms, the things that are the same. So if my staff says, oh, okay, what did you bring? What snacks did you bring? Well, I have 2 of these, so I would say 2. I've got 2 M&Ms and 1 Snickers. Okay, and all an algebraic expression is doing is replacing the thing with a symbol. So let's say, okay, the M&Ms are represented by an M and the Snickers are represented by an S. So I have 2 M&Ms and 1 Snickers. And actually I'm going to rewrite that different. So we'll say our M&Ms represented by an M, our Snickers represented by an S. And then if you knew how many you had of each one and you wanted to evaluate it, you would say, okay, I have 2 M's and 1 S, so I have 3 pieces of candy. Okay, but the terms are the separate parts after you've put together the things that are the same. So if I look at this problem again, you might want to look at that and say, oh, okay, I have 1, 2, 3, 4 pieces. But we have some like terms here. I have 3 Y's and 5 Y's, so that makes 8. So anytime you can simplify things and combine them, combine those, put those 2 together. Now I have a simplified expression that has 1, 2, 3 terms. Okay. So the terms are each piece of the expression after you've found the like terms. And then we can talk to what are the rules for having like terms. So like terms okay, they need to have the same variable and the same exponent. So we had 3y and 5y. They have the same variable. They're both y's. And they have the same exponent. These are both y's to the 1. That makes them like terms. If I had 2x and 5x squared, yes, they're both x's, but their exponents are not the same, so those are not like terms. If your coefficients are the same, so maybe 5y and 5x, their coefficients are the same, but does not make them like terms. They need to have the same variable and the same exponent, which is not the case here. So if they're not like terms, keep the pieces separate, don't put them together. If they are like terms, you can simplify them, combine those, and then once you've done that, you can count how many terms you have. Okay? And then we have some example problems, things for you to try putting it in practice for the rest of those notes. So feel free to check those out as well.